So I'm just going to share a few ways of doing part two. Part two, memory. Okay, we're just going to go through a bit. So if you're using line and line is cosine theta, dot product but cosine theta. If you want to memorize it, because now it's about cramming as much information as you can, right? So angle between line and line is cosine theta. Angle between planes and planes is also cosine theta, but it's dot product. Angle between two planes would be sine theta instead. Okay, so just this one, just take note. So once this is done, what we're going to do is you find the sine angle between BG and rectangular B. This is a plane ABCD. Now, the normal of ABCD, some of you may not know what's the normal of ABCD. Yeah? The normal of ABCD is just normal of ABCD. Just 0, 0, 1. Okay. You don't need 0, 0, H. This normal of ABCD here is pointing upwards, right? This one pointing upwards, right? This is just 0, 0, 1. Any direction parallel to it, ABCD is just 0, 0, 1. Okay. Heck, I could even write down the equation of ABCD out. You know what's the equation of ABCD? Plane ABCD, right? It's just R dot 0, 0, 1 equals 0. Okay. So just take note. If this is 0 means contains origin. Okay. So pi ABCD is just R dot 0, 0, 1, 0, 0. Anyway, this is actually the what we call the XY plane. Okay. You may want to copy it down somewhere. So XY plane, you need to know that is R dot 0, 0, 1 YZ plane is R dot, because it all passes through the origin, 1, 0, 0 equals to 0, and then after that you have got the YZ XZ. Okay, don't need to memorize if you understand how it's being derived. I gone through many times why these are so. You really don't need to memorize it, but just understand it can really. Okay, because all these planes passes through the origin, that's why it has a 0 here. All these planes here passes through the origin. Okay, and the normal can be easily deduced by looking at the graph that you're dealing with. So actually the plane ABCD can be quickly written down as R equals to 0, 0, 1, 0. Okay, then the sine angle between BG, which is this one and this one, right? So you could actually very quickly use sine theta equals to d dot n over mod d mod n. The sine angle will just be this. So actually this is a pretty fast way to do it. So this is method 1. So this is this is like a brainless way of doing it if you want to do it quick. So this is like that. This will be modulus modulus. That's okay. Then this will be h over square root 3 square 10 h square. Okay, that's how you do it. Yep, sine theta. Now the method 2 will be just using trigonometry. So method 2 is just geometry. Essentially, if you want to find sine theta, you just remember this one is like that. You use sine theta. If you can visualize it, it's good. Sine theta is here. So essentially, it's something like sine theta is equals to height over BG. this is this is much faster. This is much faster. So you use by geometry if you can visualize, like your EMF stuff, right? You what you do is you just write height over BG. You can see this the height over BG is this triangle here. Height over BG will give you a sine theta here. So that's a pretty dope. I think it's a pretty cool one as well. So you just use BG and you just H over BG. Actually, this is much faster, man. This is like cheat code to the max. 3 square. Okay. Hey, I'm showing you all this method not because you should prefer one to the other, but to help you to think in a geometrical way and also in a vector way. They are all interrelated. So whichever you want to stick to, right, just stick to. But method 2 seems very enticing to me. I'm gonna stick to method 2. Method 2. You okay? You understand what I'm saying? You understand?